Hey everyone, before I start the episode, I just want to remind you that we now have On Wildlife merch. Go to onwildlife.org and click Shop Now to buy On Wildlife shirts, stickers, magnets, and more. Also, the survey's still up. Please take it if you have the chance because I'd love to hear your feedback about the podcast. You also have a chance to win a free sticker. Okay, enjoy the episode. Hello, welcome to On Wildlife. I'm your host, Alex Ray. On this podcast, we bring the wild to you. We take you on a journey into the life of a different animal every week, and I guarantee you're going to come out of here knowing more about your favorite animal than you did before. The animal that we're going to be learning about today lives in a place where you wouldn't even think life could exist. Now, I barely know about these ecosystems, which is why I interviewed Dr. Nuno Simoes, who is a marine researcher in the Yucatan Peninsula in Mexico. Some of the stuff that he'll tell you is going to blow your mind, so make sure you bring your flashlight because we're heading under the water in caves to talk about predatory cave shrimp. The specific type of cave shrimp that we're going to be talking about today is called Criosaria morlii. And usually I give a little background info about these animals, but outside of what Nuno and his team have done, there's not much research on these guys. That's why we're going to jump right into the interview. But before we talk about cave shrimp, let's learn a little bit more about our guest.
As most of the viewers or listeners may already perceive, I'm not American. I'm not British. English is not my first language. I was born in Mozambique and eventually moved to Portugal, where I studied biology, and very soon knew that I wanted to study something related to marine biology, the sea and the coast and so on. And so I did. And eventually, I got a position in Mexico as a professor and researcher. And I started doing my research on a little bit of aquaculture, on ornamental species, marine ornamental species for the aquarium trade. And then I moved on into the ecology of some of those species in the coasts of the Mexican Caribbean and some of the coral reefs in the Gulf of Mexico.
But how did he get interested in cave shrimp?
I was in Portugal on a sabbatical leave when I received an email from a student saying, "Hey, I want to work with you guys. You are doing fantastic work. What about if we work with shrimp?" And I said, "Well, this is the right place you come. We work with shrimp." And they said, "Well, but I want to work with cave shrimps." And I kept trying to convince him to work with some fantastic biological models of sea shrimps. And he kept saying, "No, what I want to do is work with cave shrimps." And eventually he convinced me to study these cave shrimps. And that was like opening a Pandora box.
Well, that's amazing. It must be so cool to actually go into the field and view these shrimp up close. Now, many of you are probably most familiar with eating shrimp instead of seeing them in the wild. Have you ever thought about what part of the shrimp you're actually eating?
What you eat when you eat a shrimp is basically what I call a predator avoidance strategy. So all that muscle that you eventually eat with mayonnaise or whatever other recipe that you use is basically the shrimps don't use all of that muscle except when they are faced with a predator and they do their tail flips to just get out of the way. Okay, so all of this muscle is used to escape a predator.
These aren't just any type of shrimp, though. They're cave shrimp. Nuno is going to set the scene for where these animals live.
Imagine if you're in a cave and suddenly the cave is filled up with water and it happens that you can breathe because you just bring some scuba diving equipment. So some of these caves are completely dark. You need to bring all the lighting with you because there's no electricity facility that switch on the lamps and switched off. So you basically need to bring your own lighting, and you also need to bring your, obviously, the air you're going to breathe. The scenery is beautiful, but it's devoid of life. And when you start looking closer, you see that actually there's a tiny little thing running around there. Hey, what was that? And then you start fine tuning your eyesight and you kind of adapt your focus attention into a particular scale of things. And some of the caves come alive.
How is there life in a cave where it's almost completely dark? Nuno has three metrics that explain this, which are that there are a small amount of species, a small amount of individuals, and the animals that live there are physically small.
And for me, this is the indication of what I called a, a bottleneck of energy flow into this trophic web on this kind of the web of who eats what, who eats who, and so on. So this trophic web is somehow strangled. There's a bottleneck. There's not enough energy to keep the pump moving. Most of the habitats are just energy flowing uh, from one stage to the next one. Like I don't know, like one of these. When you go into a mall and you have this kind of electric stairs, they just go on and on all the time. So imagine a tiny little electric stair, very, very tiny, that doesn't go very high and goes very slowly. I mean, if you look at it, you'll say, oh, it's stopped. No, it's moving, but it's moving so slow because there's not many energy going into it. And why? Well, there's no light. And light is the engine. Light is the fuel. And you have no light. So whatever can grow under the sunlight will eventually be transported into the dark. But most importantly, they provide energy to the system by runoff. So you will have this, all the dust and powders and dead leaves and dead, insects and bones of this and seeds of that.
That's so amazing that such a small amount of just dead organic matter can support an entire ecosystem in a cave, it's just amazing. As you can tell, these caves are really cool. So let's take a quick break, and when we get back, we're going to talk about what actually lives inside the caves. The person that I'm going to recognize on this week's episode of Notable Figures in Science is Dr. Luis Alvarez, who was an American physicist. He mainly worked in the field of optics and cosmic rays, and he's well known for helping discover the east-west effect. He also researched a lot about how electrons and atoms work, which helped him figure out that tritium, which is an element, is radioactive. This may not seem like a big deal, but this is one of the ways that we're able to get energy from nuclear power. Because of all of his great work, he won the Nobel Prize in 1968. His accomplishments have made a great impact on the world as we know it. If you want to learn more about Dr. Alvarez or this series, check out onwildlife.org. So we know about their environment. Let's learn more about these awesome creatures.
Its name is Criaceria morlii. It's a palemonid shrimp, which is just, let's say, a brand of shrimps. And it's a large one compared to the other shrimps. It's not as large as the shrimps that you see in the supermarket, like the penny shrimps that you tend to eat on salads and so on. But it's an animal that you kind of relate to your hand. And that animal is basically every time we see them, they're on the move. They're just kind of blindly, running around the bottom. Kind of a bullying shrimp-like figure because he has these two massive chelas, these two massive clamps on each side. It's like a boxing shrimp. It's like, these boxers that I all the time with the arms kind of ready to punch.
These shrimp are also blind, so how do they find their food?
So you have two types of shrimps. Well, you have three if you consider mysids and shrimps. And the mysids and the attid shrimps, they are indeed completely blind. So if you observe them with a microscope, you will see where the eye used to be that there, there's only a very minute reminiscence of what an eye could be. Whilst if you look at our predatory shrimp, or that, what I call the jaguar shrimp, they are blind. They don't have eyes, no, but they have some eyes that have been with some atrophy. They've been atrophiated. They're not functionalized, but you see that there's some reminiscence of what an eye used to be in the areas. So we then set up an experiment. And being in Mexico, we're not Harvard or one of these nice universities with a lot of money. So we bought some infrared cameras that are used for home security. Not very good resolution. And we just put one aquarium, complete darkness, and we filmed them with this infrared. What you see is that there's one prey shrimp and one predator shrimp, large predator shrimp. And suddenly, this tiny little shrimp on the wall of the aquarium starts swimming in the water column and inadvertently, without knowing, bumps into the antenna of the predator shrimp. And man, that's amazing. I mean, you would see this other large shrimp jumping like a jaguar. When you see these lionesses in the savannas of Africa jumping into a poor gnu that's going to be their next meal, this guy just jumps and with his right killer in a fantastic precision, complete darkness, just grabs the other shrimp. He's not seeing anything. He just perceives a touch in one antenna. And with that perception, he can, well, I assume that he could not make a calculation like you and me and the listener, but he could understand first the direction or from where the movement is coming, the velocity of that movement, and therefore is able to do the calculations to just jump ahead, extend his right arm. It's not an arm, but whatever, his periopod, and eventually grabs the other shrimp.
It's amazing that these shrimp don't even need to see to precisely take down their prey. Because we know that this is a predator, I was interested to figure out how important they are to the ecosystems that they live in.
I think that Criaceria morlei, the jaguar predator shrimp, it's as amazing as it sounds, is one of the top predators of the cave system. And you have other predators. You have the white lady, which is a white fish, as the name suggests. And you have the blind eel, which is another powerful predator. But the blind eel, for example, I think I saw like 3 in all my life under the cave. So they're there, but they're very rare. The white ladies, they are common, but you'll never see more than 3, 5. I don't know. If you see 12 in a cave, you go like, wow, have you seen that? 12 white ladies, amazing. While these shrimps, depending on where you are, because again, each cenote is a different world. Sometimes you go into a cenote and you'll see, I don't know, 30, 50 of these animals just, running around their marathons, their inexplicable continuous marathon. So I think that the presence of this shrimp kind of helps equilibrate other species that exists there.
Okay, so now we know that they're important, but are they struggling right now?
They're endemic to the peninsula. They don't live anywhere else. If you want to see these guys, you have to go and visit us in Yucatan Peninsula. So for that reason, they are listed as a potentially endangered species. Fortunately enough, not at this moment. but it's protected. And under the Mexican law, they are protected. You have this very complex system. When it rains in place A, 3 hours later, 6 hours later, the water level on a cenote 5 kilometers away will also raises, although it didn't rain in that area. So the entire aquifer of the peninsula is connected. If you dig wells and you connect the surface with the aquifer, anything in the surface will go into the aquifer. If it's organic matter, no worries. We have the shrimps and the isopods and the mysids and all the bacteria and fungi that in the caves that will eventually take care of that energy and transform that into other forms of life. The problem is when you have, chemicals, you have heavy metals, you have compounds that are not organic. So we have very strong evidence that what is the city centers induce, create a lot of these chemicals that eventually permeate through the rock into the aquifer. And it's exactly the same aquifer that we're drinking, that we're, giving water to our plants, and so on and so on. So you have a very big problem of public health, human health.
That just shows you that pollution doesn't only impact animals, but it also affects us. So, what can we do to help?
So one of the ways you can help the system is that if you go on holidays, on vacations to the Yucatan Peninsula, you select those cenotes that demonstrate to have a sustainable approach to their touristic exploitation. There are many, many cenotes that are running very well. They take very good care of the system. And perhaps those will end up being slightly more expensive or slightly more far away or something like that. But we're working on a platform that will tell you, look, you can go and visit 100 cenotes, but these 20 ones here are well managed. They are managed towards a sustainable way where you'll have the minimal impact on the vegetation and the underwater fauna, including the shrimps that you mentioned that we've been talking about. So I believe that being a responsible tourist is a way to help this. Another way to help is to support initiatives that will make the persons that depend on these cenotes to live better. And this is kind of a broad answer to your question, but most of these cenotes are in rural areas where the local villagers or the villages that live nearby, you'd be surprised. Most of these people are, on the brink of, I wouldn't call misery, but they are certainly very poor. So they see the cenotes and the touristic exploitation of the cenotes or whatever other activity that may have a damage towards the cenote, like work on a pig farm or, I don't know, work on whatever other activity that can have an impact. And if they don't have any other alternative, they will keep working on the pig farm and they will be upset with you if you come and say that the pig farm should close. Or they will continue to do agriculture and use pesticides that will eventually go into the aquifer. Or they will open up that cenote and they will charge you 20 cents for you to participate in the cenote. So our group from Cenoteando, we're proposing initiatives that inform the tourists, not the mass tourism. That is difficult to inform. But one of the reasons I'm in this podcast is exactly not only to talk about the biology of a fantastic species like the jaguar predator shrimp, but also to raise awareness on these ecosystems and the problems that they face. And we're working with some communities to promote sustainable tourism. So instead of paying 20 cents, maybe you can pay, I don't know, $2 or $20. And that will make a difference. That will surely make a difference because you're keeping a good management, best practices approach to do tourism in the cenotes. That goes through, doing carrying capacity studies, increasing. the alternatives. It's not only the cenote. There's other things you can do. Enjoy the local food and stay in a local house. It's what we call ecotourism. And I know it's not for everybody, but I don't know. I assume that the listeners to your podcast are not the average Joe, citizen Joe going around. Not what I'm trying to say is that not many people is interested on, endangered species. So this is a particular one, and is just a representative of what I would say an endangered habitat, which is the cenotes.
Yeah,
which are the
absolutely.
cenotes.
Yeah, and you brought up so many great points, and you've shown that it's such a complicated issue because there's so many different types of people involved, and some people rely on these activities for their livelihoods. And yeah, so practicing responsible tourism is an awesome way to help out. So, Nuno, thank you so much for coming onto the podcast. I learned so much, and I'm just really glad that you were able to share your knowledge with all of us.
Thank you, Alex. It's been a pleasure to talk to you. If you have the possibility, just I would like people to know our project, cenoteando.mx. I'll provide you with a link so you can eventually add that. Any help is welcome. We collaborate with a lot of institutions, from the National Geographic to academic institutions and so on. So coming to this podcast has been wonderful. It's been kind of difficult to tell you all of this in my clunky English, but I hope I didn't make too many mistakes and you enjoyed this. Thanks so much, Alex. Been a pleasure.
Thank you. I absolutely enjoyed, and that link is going to be on our website.
Nuno taught me so much about these amazing creatures and the ecosystems that they live in. And like he said, these cave ecosystems are extremely delicate, and they're being hurt by people right now. This is why it's important to support organizations that protect cave organisms. You should absolutely go check out Cenoteando and Biodiversidad Marina de Yucatan, which are organizations that Nuno is a part of. Thank you so much for coming on this adventure with me as we explored the world of the predatory cave shrimp. You can find the sources that we used for this podcast and links to organizations that we reference at onwildlife.org. You can also email us with any questions at onwildlife.podcast@gmail.com. And you can follow us on Instagram at on_wildlife and on TikTok at onwildlife. Don't forget to tune in next Wednesday for another awesome episode. And that's On Wildlife.
You've been listening to On Wildlife with Alex Ray. On Wildlife provides general educational information on various topics as a public service, which should not be construed as professional, financial, real estate, tax, or legal advice. These are our personal opinions only. Please refer to our full disclaimer policy on our website for full details.